So the last thing that we look at in this chapter, the first three examples were all about putting in numbers and seeing what would come out of the two functions. And we looked at ways that we put in numbers if we had tables, how would that work if we had the graphs, how would that work if we had the equations. But what we started with at the beginning of this lesson was looking at, we had our blue machine and our red machine, and then one of them broke, and now we have our new green machine. How could we, if we had two equations, find that new machine, and what would it look like? So here we have f of x is 2x squared plus 1. G of x is 2x plus 7. So I'm going to make an f machine here. Woo! Our G machine is a little bit old, bent. So this one is f of x. This one is g of x. And we're trying to find the new green machine that combines them both. So if this was f of g of x, which one do we do first? G of x. So it would be imagining g of x, then f of x, and we're trying to figure out what the new machine would be that would do both of them. That's connecting to what we started with. So now algebraically, what does this look like? We have g of x inside of f of x. So first thing that would happen is x would go into g of x. Well, what would come out? If I put x into g of x, can you see that out would come 2x plus 7? And now you need to put 2x plus 7 into the f machine, into f of x. If I put 2x plus 7 into f, what does f do to whatever you put into it? It squares it, times it by 2, and adds 1. So what are we going to have to do to 2x plus 7? We're going to have to square it, times it by 2, and add 1. If you left it like this, that would be fine. If your answer is simplified, you might have to square the 2x plus 7, FOIL that out, multiply that out, then multiply it by 2, then add 1, and see what the new equation is. So depending on if you're checking your answers with the answer key, if it's simplified and multiplied out, you might have to do that. Sometimes it might be kept like this. In fact, this is kind of factored and kind of nice in a lot of ways. So I'm going to just leave it like this. B is g of f of x. That means you would do f of x first, then g of x, and find out what your new machine would be then. Well, if we did f of x first, if you plug an x into f, what comes out? 2x squared plus 1. And then 2x squared plus 1 has to go into the g function. If we would do that, what does g of x do? Whatever gets put into g of x gets multiplied by 2, and then you add 7. So if I put in 2x squared plus 1, I'm going to multiply it by 2 and add 7. Yes? So you're asking if you have to write this step? I would write that step. It doesn't take that long. And if you make a mistake from, like, on an exam, this step would probably be assigned a mark. And then if you make an algebraic or even a notational mistake in your next step, then the marker can't tell where did you get that from. And again, it doesn't take long to write it down. Now this one, because I'm not squaring anything, it's going to be relatively simple to simplify it. Distribute this 2, you're going to get a 4x squared plus 2 plus 7 will end up with a 4x squared plus 9. I'm going to erase A so that we can do part C. G of x, that means it went into the G machine, it went into the G machine again. What would come out? Well, the idea is the same. If you put x into the G machine first, what would come out? A 2x plus 7. And then if you put a 2x plus 7 back into the G machine, what it does is whatever you put in gets doubled and you add 7. So now I'm putting in 2x plus 7. That 2x plus 7 is going to get doubled and then you're going to add 7. Again, this would be one that's easy to simplify. You're going to get 4x plus 14 plus 7, 4x plus 21. Questions 10 and 11 for practice.